Hello friends, welcome back to my channel Nishandar. Okay, today we're going to cover the last point on this topic, the gas turbine jet propulsion. That is the last point is the rocket engine. Hopes you are enjoying all the previous videos. Please go through that each videos. We cover the previous, that is the air breathing engine, that is the turbojet, turboprop and the ramjet. Okay, today we see the non-air breathing engines. Okay, let's start with the difference between the basic difference between the air breathing engine and the non-air breathing engines. Okay, in air breathing engine we see that is we call as a jet engine. Okay, what happens in the jet engine? In jet propulsion, the oxygen required for the combustion is taken from the atmosphere and fuel is stored. Okay, but in rocket propulsion is very important that in rocket engine, the fuel and oxidizer, that is oxygen, both are contained in the propelling body itself. So rocket engine can function in vacuum also. And the fuel and the oxidizer are commonly known as propellants. Okay, the combination of the oxygen and the fuel we call as a propellant, and that propellant and that is the fuel, we can also say the fuel is maybe in solid propellant or it may be in liquid propellant. It may be solid form or maybe liquid form. So we understood the what is the main difference. In jet engine we suck the air, atmospheric air, and fuel in carried in CC combustion chamber, but in rocket engine both are available in combustion chamber, that is the fuel and oxygen. This is the main difference in the rocket engine and the jet engine. Okay, we know that rocket engine, it can travel in vacuum also. Okay, so to get into space we need a lot of energy to overcome the earth's gravity. So the main purpose of a rocket engine, we produce in high thrust to overcome the earth gravity. Okay, above the 30 kilometers there is no atmosphere. So I told the previous slides, we carry there or oxidizer tank. The gravity lets the earth hold onto its atmosphere only, but above 30 kilometers there is no atmosphere. The space shuttle burns oxygen just like a car engine. Okay, now we see on what is the actual difference in car engine, jet engine and the rocket engine. Let's start with the car engine, how it works. We know that to car engine works on principle of the Otto cycle, diesel cycle. Simply that a chemical energy is converted into the mechanical energy. Okay, and that mechanical energy is utilized to overcome the opposition. Opposition means to overcome the friction, to overcome the air resistance. The what amount of power developed during the combustion, and that power is coming to mechanical energy, and that mechanical energy is this power is overcome friction, air resistance. Okay, we see here that applies a force to turn the car wheels and the push against the road surface. That the same phenomena it works and the car moves forward. So my purpose is that this slide, what amount of power developed, and this power is utilized to overcome the friction and resistance. Like that in rocket engine we have to produce in thrust such a way that to overcome the earth gravity. I will see in the jet engine how it works. Aircraft engine burns petrol, kerosene or fuels and releases the chemical engine thrust and turns turbines. We know that we run the turbine with the exploring the air and the burning the fuel and that combustive products. We propel the some turboprop, also we produce the thrust and the airplane moves forward. Okay, so again in this case which overcome the drag force of the air, and because of the high thrust force the airplanes can fly and the plane moves forward. Now what happened in the rocket engine? Now rocket engine on which principle it works. Okay, I told We produce thrust such a way that it works on a principle Newton's third law. There is every action, there is equal and opposite reaction, and the rocket moves because of the reaction principle. The rocket engine burns oxygen and exhaust gas pushed backwards at the enormous speed. Okay, now there is quite interesting on the orbit, how to maintain the fuel for long years. Okay, there is no need when we reach at the orbit. Okay, there is no need of the fuel. Once it's get in orbit, there is no need of any fuel to push forward. Okay, we know the Newton first law. When object is there is no any restriction, no any obstacle, then object is continuously moving. Okay, that is the rocket reaches orbit and no longer needs to burn any more fuel. No net force on the rocket. Okay, is very important. There's no any restrictive forces to obstacle this movement of that satellite. Okay, the gravity exactly balanced by the rotational force. That is weightlessness. Now the rocket history. Okay, the world's first artificial satellite is launched in 4 October 1957. Okay, we see the Vostok 1 and the Yuri A. The Gagarin, the first man in the space, in 12 April 1961. And we know the Apollo 11 and Neil Armstrong, the first man on the moon, on the 20th July 1969. This is the rocket history. Before going to that, covering the part, we must know what are the development, what is the history. So I purposefully prepared this slide. Okay, now starts with the rocket engine. Is classified in two groups, the solid propellant and the liquid propellant. First we starts with the solid propellant. If you see in the animation, there is one barrel and is filled with the some solid grains. Okay, what is the material of that grains? We've seen further slides. It is nothing but we call as a propellant. It is the combination of fuel and oxidizer. Okay, is burn like a cigarette. Okay, if you see, is there again classified solid propellant two groups. There's a restricted burning. If you see the restricted burning and the unrestricted burning. Okay, what is the purpose of restricted and unrestricted? We see in further slide, no problem. If you see in the restricted burning, we refer the slide number A image. Is burning is only at the ends only. Okay, but if we see in unrestricted, there are possibility when we start burn with the help of some igniter is there, the burning simultaneously takes place from all sides. If you see here, the burning takes place from the all sides. Okay, what happen if the burning is simultaneously burn, and if burning is a start from that end only, what happen? If you see, I mentioned if burning is carried out from at one end only, we get low thrust, long burning. Okay, and if burning simultaneously from all directions, that is unrestricted burning. Okay, we get high thrust, short burning. Okay, and if we fill the granule shape such way that again classified hollow cylinder, cruciform, multiple grain, single grain, star grain. Okay, if we see in the animation also, there are the small propellant. We fill in the one barrel. Okay, and if we ignite at one end, if we see at one end only, it starts to burn and producing high thrust. Okay, if you see, I mention here high thrust, short burning. Okay, means what? If we unrestrict the burning, if we prefer, we get high thrust, means you get maximum altitude, but for a short duration. Okay, but in case of if you burn at only restricted manner, we get low thrust, that is low altitude we say also, but long duration. That's the main difference. Okay, now what is the propellant? Okay, we say I have said a granule form. What is the material is that? As a fuel we use asphalt and oil, rubber, and the resin. And for the as a oxygen, there is the sodium nitrate, ammonium perchlorate, and the potassium perchlorate. And the combination of these as the propellant, that is the solid propellant. Okay, if you see here figure, this is the solid propellant is the granules, and in shape we see there is a star shape. Okay, there are different types of shape is there, and it shows here in figure burning surface how it burns. If we see as an arrow at one side, one direction only, it burns, and the reaction force is that here, that Newton's third law. If we see the shape like that, the burning areas is shown by the arrows, the burning surface, internal boring surface, internal star shaped burning surface, the end burning surface is there, and at the end is provided with the convergent divergent nozzle. Okay, where the subsonic velocity is going to convert into supersonic velocity. The solid propellant is the combustion chamber. This is the combustion chamber. Is simply in the we see in the some other rocket. Okay, simple. The crackers in the Diwali we burns like that. Same principle, that is solid propellants. Okay, simply. Okay, as the some the solid propellant application are shown here. If we see here, okay, these are the solid propellants. We have to launch any satellite or the rocket boosters. Okay, I change the highlighter color so you can easily understood. Okay, if you see here, they are the solid propellants. Okay, and they produce high thrust, and if we see at the end there is the nozzles. Okay, and these are the shapes. If you see here, what are the elements? If we see the one animation or the prototype how it works, one end, see here how the burning going on here, how it starts burning here. You see properly on this video. With some animated videos is there. We understood what is the use of the solid propellant. If you see here, there are the solid propellants. If you see here, okay, the AN5 solid rocket boosters. If you see, these are, if we see in the any booster, yeah, they are the all the solid propellants. Okay, and along with the solid propellants, there is also is the liquid propellant in this chamber is also. It is a multi-staging. Okay. Now this starts with the liquid propellant rockets. Okay. Now we know the solid propellant how it works. Now in case of liquid propellant, how it works. You see the animation, we observe the figure. Okay, in liquid propellant rocket, the fuel and oxidizer are stored in a simple tanks. Okay, if we see, there is a fuel tank and the oxygen in the form of liquid form. There is oxidizer tank, and are fed through a system of pipes, valves, and the turbo pumps to a combustion chamber. Okay, the oxidizer and the fuel is pumping in the case in the combustion chamber. Okay, again the pump is again run by the some turbines. Turbo pump is there. That's simply gas turbine, because that again gas turbine is run on the fuel and oxidizer, and once the power is generated, that the small turbo pump is there, and the developed power is again utilized to run this pump. The simply small turbines are there in the liquid propellant rocket engine. Okay, if we see here, the feed, the fuel and the oxidizer, some liquid propellant tank is the pressure feed. There is no need of pump, and at high pressure they are feed in the tank. If we operate the valves, they at a high pressure forced through this chamber. Okay, here the pump operated. Okay, if we see burning start here, the injectors. Okay, the high pressure fuel and oxygen come in contact this, and with the help of some it starts to ignite, and the combustible products, because of the combustible product, what happened, that subsonic flow is converted into supersonic flow. If you see the nozzle, convergent divergent nozzle is there, and this is the combustion chamber. Okay, if we see in the figure, this is the convergent divergent nozzle, and if we see the some fuel pipes are wrapping over this nozzle. Okay, because this is nothing but the with some amount of fuel is carrying and is wrapped around this nozzle, because of this thrust force the high temperature generated, and because of material consideration we have to maintain the temperature. We cool with the help of fuels. Okay, we cool this maintain the temperature of that nozzle around them with the help of fuel. Is very important in case of liquid propellant rocket. If you any launch the satellite, if we see in the previous figure, if we see this is the solid propellant, and if you see here is the liquid propellant engine, is a multi-staging. Some altitude is carried with the help of solid propellant, because the main disadvantage of solid propellant is if we start burning, okay, there is no control. But in liquid propellant we can control the flow rate, the thrust force is in control in case of liquid propellant engine. If we get some high altitude with the help of solid propellant, and then after we use the liquid propellant engines to carry this further altitude or the changing the altitude. That is the comparison between the liquid propellant and the solid propellant. If you see the solid propellant, there is one igniter, and these are the granules form, the combination of the fuel and oxygen. And if you see, there is the liquid fuel tank and the liquid oxidizer. It comes in contact, burns, and the produces thrust. Okay, there is one video you can easily understood how it works. I start screening. Okay, there is one animation here. We see how it works again. Okay, hopes you enjoying this topic and understood how it works. Okay, there is one animation here how it works, or how the rocket engines are launched. See here, if you see here, this is the solid propellant. Initially the thrust is actually with the help of some that solid propellant. Okay, after that thrust is the tank becomes low, weightless if you all the fuels burns. Okay, and further that we can travel with the help of them liquid propellant engines, the step by step. If it burns, that is the going to weightlessness and carry next stage. Like that it works. If you see the liquid propellant engine now. Okay, once you get in orbit, there is no need of the fuel further. See, there's how it launched the satellite, the step by step. There's the liquid propellant stages going to weightlessness. Okay, hopes we enjoying this video. All the materials I have provided with you. Because of this lockdown, we prefer this channel for the more understanding of the student. Hopes we enjoy. Please give feedback to me for more suggestions, and I'm going to continue this channel for the more videos of the mechanical engineering as well as thermal engineering, IC engine, and the refrigeration air conditioning. So for more update video, please subscribe my channel Nishandar. Thank you very much.